Yeah, this lesson is on altitudes of triangles. So we did medians in the first part, and so this is the altitudes of triangles. Okay, so how can we find the balancing point or center of gravity of triangles? Okay, so that's what medians and altitudes are. Okay, all right, so recall when two or more lines intersect in the same point, they're called concurrent lines. Okay, and an altitude of a triangle is any segment that's perpendicular from a vertex to a line that contains the opposite side. Okay, so altitudes can be inside the triangle, they might be outside the triangle, or they might be on the triangle. So for example, here's triangle ABC right here. Okay, so it's easy to see this altitude right here. It's inside the triangle, altitude CY. But if I wanted to do an altitude from point B here, what I'd have to do is extend this side out here so I can draw a perpendicular segment that connects the line of the opposite side. So to get that altitude, we need to extend that side of AC. So let's do that. And then right there, then we can draw the altitude. The altitude is a perpendicular segment that goes to a line that contains the opposite side. What if I wanted to do an altitude from point A right here? Okay, it'd have to be somehow perpendicular to this side right here. Oops, I'm sorry, you can't see what I'm doing. If I was doing from point A right here, it's going to have to be somehow perpendicular to this side. So I'm going to have to extend this line out here to make that perpendicular. So that's what that says right there. And then we can go ahead and draw a perpendicular segment from point A. Just, try to guesstimate a nice right angle right about there. Okay, and we'll call it point X right there. Okay, now you'll notice I have that little point P hanging down there. That wasn't supposed to be there, but what that point P is, it's going to be where all three altitudes intersect. So this altitude and this altitude and this altitude, they're all going to intersect somewhere up here. Can you imagine if we extended those lines with a nice straight edge? If we did it right, then so let's go ahead and extend all three altitudes to intersect at the same point P. Okay, so right there, that is called the orthocenter, where the altitudes intersect in a triangle. Okay, so let's go back here. So the point of concurrency of intersecting lines of a blank triangle, of intersecting lines of the blank of the triangle are called. Okay, so sorry, my wording is getting a little bit long here, or awkward. Sorry about that. So here I'm going to insert perpendicular bisectors right here. So the point of concurrency of the intersection of the perpendicular bisectors, that was from about 5 lessons ago. That was called the circumcenter. How about the point of intersection of the angle bisectors? Well, that was right after the circumcenter. That gave us the incenter. The medians was yesterday, so that gave us the centroid, and today the altitudes make us the orthocenter. Okay, and all three of these, or all four of these, they're all concurrent lines. The angle bisectors intersect in the same spot, so do the perpendicular bisectors, so do the medians of a triangle, and the altitudes of a triangle. So they're all concurrent with each other. Okay, so here we have a graph here, and we're going to locate the orthocenter. So what we're going to do is draw a couple of perpendicular altitudes to the opposite side. I think it's pretty easy to just go straight down this one right here. That would give us an altitude right there. Okay, so there's that altitude right there. And then, I'm sorry, I keep thinking you can see my cursor, but you can't. So go straight down from this altitude, or from this vertex. It'll give us this altitude, so a nice right angle. Let's try over here next. So I'm going to go straight over. I'm not going to go over here because that's not a right angle. I got to go from here, right angle, right angle, right angle, right about there. So that's going to give me a right angle right there. Okay, and then where those points intersect is going to be our orthocenter. So our orthocenter here on this one is 2, 2. Okay, one more of these, you guys. All right, let's do that with this one here. So it doesn't matter which altitudes you draw. If I did it from this vertex right here, it would have to go perpendicular to this side. If I did it from this vertex right here, it would have to go perpendicular to this side. So I'd have to extend that right there. And if I did this altitude, this one's easy. I can just go perpendicular to that. So I think I'm going to do this one first, and then I think I'll do this one second. Go straight down, and then just take this one straight over. And then where the altitudes intersect is going to be our orthocenter right there. Okay, so there's that one. And then let's do it. Go ahead and extend that line, and there's that one. And then where they intersect, I see them intersecting right here. Looks like at over 9 down 1, so 9 negative 1 right there. Okay, that's what the orthocenter is right there. Okay, all right. Remember, perpendicular bisectors they bisect the sides of a triangle, and they're perpendicular. They give you the circumcenter. And then angle bisectors, they give us the incenter. And then yesterday's lesson was the medians. The medians go to the midpoints of the opposite sides, and they give us the centroid. And then the altitudes are just perpendicular to the opposite side. They're not bisectors, they're perpendicular. Sometimes those altitudes are inside or outside or on the triangle. Anyways, that gives us the orthocenter. All right, if you guys are in my class, that's going to be your assignment. Take care.